We're first going to compare two different scenarios about this train. A train is traveling across the country, and upon entering Oklahoma, its distance traveled within the state is given by y equals 70t, where y is in miles and t is in hours. So we have the picture of our distance versus time graph based on that equation y equals 70t. So when we're answering these questions, we can be taking a look at different aspects of the graph. How far does the train travel by t equals 2? So we're going to start at t equals 2 hours, take a look at the graph, and we're going to see that that is the point 2 comma 140. So we know that it's been traveling 140 miles by the time it reaches 2 hours. How fast was the train traveling at t equals 2 has to refer to your derivative. So we're talking about the value of the slope of this particular line. In this case, that's going to be 70 miles per hour. And again, we can do the same analysis for really any of these different time values. How far does the train travel by t equals 3? So again, if we take a look at what happens at t equals 3, we're at the point 3 comma 210. So we know it's 210 miles is the distance that's been traveled. And how fast was the train traveling? We're again referring to the derivative, and it's still 70 miles per hour based on the slope of the line that we have. Now, what if we changed it around a little bit? What if we said the train is still traveling, still entering Oklahoma, and it reaches a level of straight track and can travel for 3 hours at exactly 70 miles per hour? So instead of having a distance versus time graph, we could consider the speed versus the time. So in this case, our speed would be a constant 70 miles per hour over the course of the 3 hours. So again, we want to try to answer some of the same questions. Now, the questions revolving around how fast the train was traveling is still very easily answered because we know it's going to be a constant 70 miles per hour. But the question to be able to answer is how far has the train traveled? Now, one of the ways that you can figure this out using arithmetic is the idea that distance is equal to rate times time. And if we're traveling for 2 hours, for a total or at a rate of 70 miles per hour, we can multiply the rate times the time to get a total of 140 miles per hour. The question is, how do we read that on the graph? On the graph above, when we were given our distance, we were able to find the velocity by using a derivative. But this time when we're given our speed or we're given that velocity and we want to try to find out how far we've traveled, we need to analyze this graph in a different way. How do we come up with the 140 miles per hour by this particular graph? Well, we're going to use the model of rate times time. Along the y-axis, we are talking about the various rates. And across the x-axis, we're talking about the various times. And if we want to find the product of a rate times a time, it's similar to finding an area. So the area of this particular rectangle that we have here would be equal to 140. The 2 hours across the x-axis, 70 miles per hour across the y-axis, multiply them together to get 140. To answer the other question about how far we have traveled by t equals 3, we would consider what happens over the course of 3 hours traveling at 70 miles per hour. So this area of length times width would represent how far the train has actually traveled. The 3 hours times 70 miles per hour would be equal to 210 miles. So what does this mean for us? That first scenario gives the it graphs the train's position over time, and the second graphs the train's rate of change over time, which is essentially your derivative of your position. So then the area under that curve, the area under the derivative curve, represents how far the train has traveled over that given time interval. So the area under f prime would be able to tell us how your function f has been changing, how far it has gone. So one example of how we can use this for a situation that's not a train, but more of a graph analysis. So let's pretend that we know, for example, that f of 0 is worth 10. That is a starting point. We know that at x equals 0, y is going to be 10. Here we have the picture of our derivative, and we know that the area that we can find for a is going to have an area of 5. So this area right in here is all worth 5. And the region for b has an area of 9. So what can we infer about what happens with the graph of f? So this area of 5 that's hidden underneath here with a talks about how the function f is going to be changing. So if we started at 0, comma 10, by the time we get to x equals c, we know that we've had a change of 5. So we're going to take the 10 and add the 5 to it to end up at a final result of 15. So our function f started at a y value of 10, and by the time we got to x equals c, we have a y value of 15. Then what we're going to notice is that there is a change that's underneath this curve. So if you think about maybe doing a multiplication, like what would be the length times the width of this area, we are using a negative value for the height of this particular region, but we're still using positive x's. We're still working from the left to the right for positive x's. So by the time we get to point D, we've actually lost 9 in our value. So we started with the 15 that we had at C, and we're going to take away the area of 9 that's below the curve. We'll end up at 6. So what we know is we started with f of 0 is equal to 10. By the time we get to point x equals c, we're at 15. And by the time we get to x equals d, we're back down to 6. So the area that's underneath the graph of our derivative can help us describe how much f has changed between specific x values. We are not able to interpret what happens in between 0 and c, or what happens in between c and d, but we do know those 3 specific x values and the corresponding y coordinates. Your final task is to take a look at this final problem, which is talking about driving on the highway. You're passing a truck and then you're slowing down to a moderate 60 feet per second as your velocity. So the question is, what would be some of the different distances that you're traveling in this scenario?